So we are going to prove triangles congruent today, and we're going to look at the angle side theorem and the hypotenuse leg theorem. So the first one we're going to look at is angle side. So we have the two angles and the non-included side. So when I'm looking at this picture, I'm noticing how the side that we're using only touches one of the angles, just like it does when we write out that statement of angle side. Okay, so we're going to try this proof. And as always, we're going to start with our given. Now, they get a lot of givens this time. So we're going to write them all down and keep in mind we probably need to use all of them. So we have AB is perpendicular to BC. We have DE is perpendicular to EF. We have parallel lines. So we have BC is parallel to EF. So far, none of those are congruent statements. Here's the only congruent statement that we get. AB is congruent to DE. So we only have one. I'm going to go over and mark it. AB is congruent to DE. I have to think to myself, I need to find two more congruent statements before we can prove triangles congruent. So first thing I'm going to do is look at the perpendicular information. So we know to begin with, perpendicular lines are going to form right angles. So I would find, since AB is perpendicular to BC, a right angle at B, and since DE is perpendicular to FE, I'm going to find a right angle at E. So I can say angle B and angle E are right angles. So for a reason, we know that perpendicular lines form right angles. Now, we don't have them as congruent, so that's our next step, because we're on a mission to find congruent statements. So I could say angle B and angle E are congruent, and we know that because all right angles are congruent. So there's two congruent parts. To use the perpendicular, the next thing we have is our parallel lines. So now we have to go back and think when we had our parallel lines. We looked at statements with like alternate interior, alternate exterior angles. So if I'm looking at these lines here that are parallel, BC and EF are parallel, and take a look at this transversal, that should show me these two angles. Those two angles are alternate interior angles. So we are going to label those, and we're going to label those with three letters. I can see angle BCA is congruent to angle EFD. And we know that those are alternate interior angles, so we're going to say over here, alternate interior angles are congruent when the lines are parallel. So that gives us three congruent statements. That's your pass to say, okay, look at the triangles. Does it fit into one of our 5 methods of proving triangles congruent? And it does. It fits into our angle side. I know it's angle side, again, because the side that I have congruent only touches one of the congruent angles, only touches the right angle. It never, when I trace it out, touches the alternate interior. So for our final step here, finishing off our proof, we can say triangle ABC is congruent to triangle DEF, and we have our reason of angle side. Okay, so on the back, we're going to take a look at that hypotenuse leg case. Now this one's going to be a little bit different and a little bit longer, and when we get to the end, I'll kind of try and show you a shortcut for this proof. So notice what it says. If the hypotenuse and leg of one right triangle, big key thing here that has to be true, has to be in a right triangle. It says it only works in right triangles. Okay, so if the hypotenuse and the leg of one right triangle are congruent to the other hypotenuse and leg of the other right triangle, we can say they're congruent. So if you're looking at the picture, notice it kind of looks like that side-side angle case, but we know side-side angle doesn't work. So the only reason that we can use this is because it is in a right triangle, and it will only work if it is a right triangle. It guarantees us that 90 degrees. so we're going to see how does this work in a proof. So step number 1, you write down the given information. So we have an isosceles triangle ABC. We have CA is congruent to CB. And I'm actually going to mark that right now so I have my picture label. And then we have CD is an altitude. So that's our given information. Let's start with the altitude. So if we go back to our special segments and triangles, we know that altitudes are perpendicular lines. So what that's telling us is CD is perpendicular to AB. And our reason over here is because altitudes form perpendicular lines. Okay, so now we have a statement that says we have perpendicular lines. Well, we've used this before. We know perpendicular lines form right angles. So the right angles that we're going to get are angle ADC and angle BDC. We can say that those are right angles. And our reason? Perpendicular lines form right angles. So I have two right angles, one here, one there. Now, we would go on to say those two right angles are congruent. And our reason for that is because we know all right angles are congruent. So there's two congruent statements. Looking at our picture, I can see that CD is in both triangles. That would allow me to say CD is congruent to CD, and that's our reflexive property. So if I'm looking at this point, I could say, sure, those two triangles are congruent, but it would be that angle side side case, and we can't prove it by the angle side side. But because it's a right triangle, I have that ability to say hypotenuse leg. Here is a key step. Because we know we're proving them congruent by hypotenuse leg, I need to actually state that it's a right triangle. So here's where I'd add in a step. Triangle ADC and triangle BDC are right triangles. Okay, and the reason we know that is as long as I have a triangle with a right angle, a triangle with a right angle is a right triangle. Okay, so that gives us now enough information. This was the extra step that we needed. Extra step has to be in there. Now that we have that in there, I can go and say ADC is congruent to BDC, and that's because of hypotenuse leg. Now, if you go back to what we were actually proving, nothing to do about triangles, it's the fact that we're trying to prove that CD bisects AB. Okay, well, we've said before, if our triangles are congruent, we know parts are congruent, so we have to think. Our parts that would want to be congruent if CD were to bisect AB would be these two segments, AD and BD. Well, since we know our triangles are congruent, we know parts are congruent. So I could say, okay, AD is congruent to BD because of CPCTC, corresponding parts of congruent triangles are congruent. And then since I know that those two parts are equal, well, CD must bisect AB. And well, where did that come from? That's because I know bisectors create two equal parts. We're done. So doing this proof, I can tell you one thing that needs to be in your proof because we were doing a hypotenuse leg proof is step number 6. If you do not have in here that we have right triangles, you cannot use hypotenuse leg. One step that you can actually omit would be step number 4. You don't have to tell me that the angles are right angles. My feeling is you can always say more that's true. If you miss something like number 6, you would lose credit. So we can always state that the angles are right angles, and in the end just add that extra line to say the triangles are right triangles. So we'll do some more practice with hypotenuse leg in class, but this is just to get you a foundation of how it works and what we would need to state. Okay, hope you enjoyed this. Don't forget to like and subscribe.